When solving a system of equation, we're looking to answer one specific question. We should be given two lines, and we want to know where the two lines cross. Okay? So as we get into other methods, you never want to lose sight of that fact. So we're trying to figure out where the two lines that we're given cross. Okay, so when we have two linear equations like so here, we've got y equals 2x minus 4 and y equals negative 2/3 x plus 4. The most kind of obvious way to do this would be, well, if we want to see where they cross, let's just go ahead and graph them. So I'm going to graph this first one here, y equals 2x minus 4. So we would start on the y-axis down at negative 4, and then we're going to rise 2 and run 1. And notice that I'm extending the line out. It's a good idea for these to keep that rise over run going, because if you only bring the rise over run over just one point, you may not actually get to see where they cross exactly. So you always want to make sure you continue the rise over run to cover as much of the graph as possible so you actually see where the lines meet. Okay, so for the next one here, I've got y equals negative 2/3 x plus 4. So I'll go up to positive 4. That's my y-intercept. And then I'm going to go down 2 and over 3, and you can actually see that our lines did cross right here. Okay, so we'll go ahead and connect our dots. And it was a good idea I extended that red line out, because it definitely didn't cross at these first 2 points. I had to keep it going until I saw that they crossed right here. So the way that we write our answer to these questions, again, when we're solving a system of linear equations, we're looking for the point where these two lines cross. So the lines cross at the ordered pair. Well, that would be the ordered pair 3, 2. So the solution, or the answer to this question, would be 3, 2. And if you wanted to check your answer, you could plug 3 in for x and 2 in for y in both equations, not just one. And if it works in both equations, then it should be our solution. Okay, I'll leave that for you guys to check the answer there. Okay, next one, we're going to solve the system by graphing. So we saw an example where the lines met at a single point. We're going to try this next one here. So what I'm going to do is, first, to graph this line on the left, I need to isolate y. So I'm going to add x to both sides. That'll give me 2y is equal to x minus 4. And then finally, if I divide by 2 on each side to get the y by itself, I get y equals 1/2 x minus 2. Okay, so that one's ready to graph. This one was ready to graph from the beginning, so I'll do, say, this one in blue, I'll do this one in red. So for the red line, I'll start at negative 2. I'm going to rise 1, run 2. And again, I'm going to extend these out fairly far, just so I'm pretty sure that they're going to cross by this time. So the red line is graphed. Again, for the blue line, I need to start at positive 3 on the y-axis. I'm going to rise 1, run 2. Again, I'm going to extend this for a while just to kind of see what's going on. And actually, what you're finding here is that these two lines, even if I were to keep extending this and make the graph bigger, are not going to cross. They're parallel. Okay? So another way I can tell they're parallel is if you look at their slopes, these two lines have the exact same slope and their y-intercepts are different. Okay? So here, this one starts at negative 2 and goes up 1 and over 2. This one starts at 3 and goes up 1 over 2. These two lines are never going to cross. And since the answer to solving a system is trying to find out where the two lines cross, the ordered pair, the answer here is going to be no solution. They're never going to cross. Okay, those are parallel lines. So you can use the circle with the slash through it, or you can write no solution. Either one of those answers in this case is fine. Okay, we've got one more to go. Again, when we're solving a system by graphing, we're trying to find out where these two lines will cross. I'm going to go ahead and isolate the y in each of these. So hopefully you're pretty familiar with how to isolate y by this point in algebra. And then I'm going to divide the negative 2 over. Just be careful, there's little mistakes you can make, like dropping that negative 2. So the two negatives here will make a positive 3/2 x minus 5. So that takes care of the first line. That one's ready to graph. And now if I go ahead and check this second one, again, if I isolate the y, I'll subtract 6x over. It gives me negative 4y equals negative 6x plus 20. And then if I divide through by negative 4 here, I should be getting y is equal to, this should give me 3 over 2x minus 5. Okay, so we're almost there. Now let's go ahead and graph the red line. We're going to start at -5 on the y-axis, so that'd be right here. 1, 2, 3, 4, 5. And then we're going up 3 and over 2. Up 3 over 2. And I'll extend my line there just to make sure I actually get a point where they cross. So down 3 and back 2 would work too. And I'm going to, did I get that right? Yeah. Really probably be a little more down there. Okay. And now that I have the red line, let's go ahead and graph the blue line. So I've got y equals 3/2 x minus 5. So I'm going to go down to -5. So it looks like we found the point here. Maybe. Let's just see. I'm rising 3 and running 2. At this point, you should start to think something weird's going on here. Okay? If I'm rising 3 and I'm running 2, this is actually the exact same line. So I actually have two lines that are smack dab right on top of each other there. So to find out, what the answer to this question would be, well, there's going to be a whole bunch of answers. In fact, since these lines have arrows and they go on, forever in each direction, there's going to be what we call infinitely many solutions. Okay, that does not mean that any number works. For example, if I chose a point out here, like if I chose the ordered pair 0, 4, that is not on where the two lines would cross, so that is not a solution. Okay, so it's not like an all real numbers type thing. It just tells you that there's an infinite number of answers. It doesn't mean that every answer works. If I try, this point, for example, since this point is on one of the lines, that would be an answer. This point would be an answer. Any of these points on either one of the lines is on both, so there's infinitely many solutions. And those are the three cases you can have when you're graphing two lines. Okay, when you have two lines, they're either going to cross at one point and you'll have one solution. And when that happens, you just write out the ordered pair. If it's -2, 7, you just write that down. You can never have exactly two solutions. I'll let you try drawing two lines that are perfectly straight and see if you can find out why. The other thing we could have is no solution. Okay, if our lines are parallel, there's no way they're ever going to cross. And then there's this case here that we just drew where there's infinitely many solutions if the two lines are identical and they're right on top of each other. And that's an introduction to graphing, solving systems of equations by graphing. We'll talk about some different methods in a little bit.